Hello and welcome to this new tutorial in Construct 3 on how to create a multiplayer card game. This is a tutorial for pretty advanced users, but please do follow along. I'll show you how it works. So this is the end result, and you can see here I have 4 windows open, 4 Chrome windows, and that's because there can be 4 players in the card game. Each player can log on, so let me just do that. Call this person John, call this person Joe, call this person Jane, and one more, that was Avril, whatever. Once the fourth player connects, all of the teams will get their cards. So the game is a typical Dutch-Belgian game with a custom set of rules, but of course this is a template you can use for playing other games as well. You can use the same principles, you can use the same logic. So in short, what this game does actually, it is a game where each player gets 8 cards. So there are only 32 cards in the game. The player who deals the cards can choose a trump card, which is one of the 4 suits here. So I've just chosen to go with none. That's also a 5th possibility. You can have no trump card. And once the dealer does that, the other team has the ability to tap. And tapping means that I have good cards, I want to go along with you, and the points will be doubled at the end of the game. So what happens here is, this is the dealer, this is the person I logged on with first. So this is the host actually. What will happen is the other players here will choose the tapping, but you have to know that there are teams. So John and Joe are playing together, paired. You can see here John and Joe, Jane and Avril, and Jane here are playing together as well. So those are the 2 opponents of John. So they each get the option to either go along with John or not. And there we have it. So this is now the starting point of the game, where you can see it's pretty small, but it's Jane's turn, it says. So, and with Jane's interface, it says it's your turn. So each of the 4 windows, it's like the computer of Jane and John and Joe, etc., with their own window open. But the only difference is I have 4 windows open on my own computer, and I do that using the remote preview functionality of Construct 3. So here you see that once I hover over the little cards here of Jane, I can use a card to put on the table. Once I choose a card, like that for example, you can see that all of the other players get their card put in the middle of the table, and this is the next player to go, Joe. And you see that all of the cards that are not applicable due to the rules are grayed out, you can't click them. Only the cards that are applicable here are usable. So that's one of the functionalities. You might see here at the right hand side we have the teams. We is John and Joe, them is Jane and Avril. This is so with every player, and you can see here which card is a trump card and if there is tapped or no. So let me complete this cycle, and you see Avril has had the highest card now. The 10 is the highest card. Never mind, I'm not going to explain every single rule here, but it's the principle. And now Avril has got the best cards, so he has obtained the cards, and you can see the last cards here up in his interface and in everyone's interface. Now it's Avril's turn, and I can choose this one, and then we go along like that, and it's his turn again, and so the game goes on. So once every card has been played, the points will get displayed and the points dialog, the next round will start. So let me get some terminology straight here before we start. Putting a card on the table is called a turn. This is called a turn, and the 4 turns together for each player is called a turn set. So it's John's turn now. Another turn set. Once all of the turn set have passed, so those 4 turn sets, let me just finish this up here. I'll do it pretty quickly. Now every point is counted here, and the host, which is this player in this case, John, we have to click the dialogue, and then we go to a new game where the next player has to choose a trump card. So the last thing I want to mention before I go to the code is actually that what makes this game a bit more tricky to make is the fact that every player in his window has his cards in front of him. So John here has the cards in front of him, and his teammate is opposed to him. Joe has his cards in front of him, and his teammate, being John, is opposed to him. Same thing for Jane and Avril. So it's all respective to the player that's actually sitting in front of his computer, to make it more easy for that player to follow along. So we have to take that into account when creating a game. So let me here show you. I've opened Paint because one picture says more than 1,000 words. I want to show you first, in like a drawing, how the communication works. So let me first draw this rectangle. This is the messaging server from Syrah. Syrah has a messaging server where you can log onto into a room, and every player logging onto the same room is joining the same game, actually, basically. So John, Joe, Avril, and Jane have just joined the same room, and that's why they can start playing together. But let's do this. There's 4 players. They are all logged on to that room. But the first player to log on is the host. And all the other ones are peers. P for peer. So they all log on here. Also log on here. At the moment they all log on, they are all registered with the host. So the host knows the 4 players. Once he knows that there are 4 players, he can start the game. And he does that actually by broadcasting messages to the peers. Let me just show that in another color. He will broadcast those messages to the peers. What happens is he shuffles the cards. He will broadcast those cards to the different peers. They will get the cards on the table, and then it's the first player to choose trump. If the host is the player to choose trump, he will just get the dialogue. Otherwise, he will send a query to the player saying, I want you to make trump. The player will get a dialogue, and then he will send his response back to the host. Response. Once he does that, the host will then, in its turn, broadcast the trump card back to every host. And the same happens with choosing the tapping, and the same happens every time a player has to choose a card. For example, this player has to choose a card to put on the table. The host says, okay, it's your turn, please choose a card. The player says, okay, I want to make that card, I want to play that card, and then the host will broadcast that choice to every other peer, and their instance of the application, their window, will put the card on the table at the correct place. Everything works in that way. So the host is the master, and he will orchestrate everything in the game. You can see the game is full with checks. If I'm the host, then I have to broadcast, for example. So that's in essence how it works. This is you need to know what you need to know to follow along in the code in a few minutes. So let's get to it. So here's my remote preview. I'll just shut it down. So this is the main layout of the game. I highly recommend you to read the README first. It's got a lot of things I just explained and some more details on the rules of the game, which I'm not going to explain right now, or it would be a lengthy video. So what is happening here? The background layer just consists out of the green background here and the white details pane at the right hand side. So this details pane contains the teams, contains the dealer, the trump card, the tap, and the last cards. So that's just on the background layer. The trump icon is a sprite with 6 frames. So let's see here. The trump icon, when you choose trump, you can see you choose one of either. And there's also an empty spot to just show nothing when nothing has been chosen yet. That's the easiest way. Now how does putting cards on the table work? Well, putting cards on the table for each player is done with a placeholder. And there are actually a lot of placeholders. What you see now are the 8 placeholders for the player, or for the players, multiple, when there are still 8 cards in the game. This placeholder 7 layer is for when there are only 7 cards in the game, only 6, only 5, etc. You see? Depending on how many cards for a player there are in the game, placeholders 1 to 8 layer is used. That's how it works. Such a placeholder, let's go to here. Such a placeholder actually has a player, an index, an ID, a peer, and a layout. What does it mean? The ID is fixed. These placeholders have ID 0, these have 1, 2, and 3. A player, when he logs on, depending on the order the player will log on, will be designated a team. So either these 2 players or another 2 players. This team vertically is called the W team. The horizontal one is called the Z team. So players can be W1 and W2 or Z1 and Z2. In the game this is called the distribution. When the game will start, you'll see that in the code. Each player logging on will be granted a distribution. W1, W2, Z1, Z2. And then, based on that distribution, the players will be assigned their place. And then the player will be designated here. This is the cards for W1. But for other players, for example, the second one, these might be the cards for W1. And for the third one, these will be the cards for W1. The fourth one, these will the cards be, for W1. So it changes depending relatively on the player sitting in front of the cards. The index is the number of the zero-based index of the placeholder. The peer will be filled in at runtime and will identify which peer holds the card, and the layout is corresponding to the layout, one of the 8 layers here. So this is for layout 8, and if we hide this one, you will see this is for layout 7, for example. So this is what happens with the placeholders. The cards themselves are in the layers card. Here are the cards at the bottom. A card has 2 animation frames actually. I'll double click one. You see it, the first animation frame is the front facing animation frame, and this is the back facing animation frame. So cards also have a number of instance variables. With suit, which can be S for spades, I have it here, S for spades, H for hearts, D for diamonds, C for clubs. And the value, there can be a 7, an 8, a 9, a J rather for jack, a Q for queen, a king for a K for king, an A for ace, and an M for the 10. Yes, because the game just works that way. That's the value. And then there's a permutation number. Actually, each card of the 32 card deck will be awarded a permutation number, because that's the way the cards are shuffled. The peer is the peer holding the card, and then there are two helper instance variables, which I'll come back to in the game. So it's got the move to behavior to make the cards move into place, and there's an effect, a contrast effect, to make the cards appear gray or bright. That's it. That's done with a contrast effect. There are also a number of black blocks here and there. For example, the black blocks are just reference points. There's a reference point for each player, and this represents the x and y coordinate of the location where the cards have to move to when the turn set is complete. The pink block here is the dealer starting point from which the cards are dealt and moved to their respective placeholders. The background also contains the player names here. They have been hidden now, but normally there are player names here. You've seen that when starting the game. And next to that, there's just a generic title just above the player, just to see display more information. So it's your turn, or it's that person's turn. That person has to choose trump and stuff like that. That's also on this layer. So that's pretty much it. Let me go to pretty much it. What I wanted to say too is that there are several dialogues, of course. This is the dialogue for connecting. This is the dialogue to show the points, a dialogue to show the tapping, a dialogue for the trumps connection. And when some player disconnects, you get a little dialogue saying a player has disconnected. So there are several event sheets, 5 event sheets in total if you don't count the README. And I'll start with the game layout. So here, this event sheet contains a vast number of variables we'll use in the game. So I highly recommend reading the README first. On the start of the layout, some init things need to happen. So the player distribution and the player names dictionary hold a mapping of the distribution to the peer and the mapping of the peer to its alias. I know that there is an my alias expression in the multiplayer plugin, but to my experience it doesn't work very well. So what I've done is I've created two arrays, player distribution, player names. In the player distribution, I map the W1 to the peer ID of the person being W1 in the game. And at the player name, I say this peer ID is actually has this alias. That's what I do. So I use them all the time in the code to identify the players. So here they are just cleared. I initialize a value that takes care of the fact that the user cannot click the login button twice. The Advanced Random plugin is used to shuffle the cards. In order to do so, every card has gotten a unique number of 0 to 31. The Advanced Random plugin will pick a number corresponding to each card. So, and then we call the connect function to connect to the multiplayer signaling server, and we'll come back to that function in a moment. We stop the animation of the trump icons so the frame can be set later, and then we hide all of the dialogues except for the connection dialogue. We do some more setup. We pick all of the trump cards, the one on the background layer and the ones in the drum dialogue, and we just initialize them. And then we pick all the cards, and we stop the animation and put the animation frame to the correct card. So the last cards are these cards here at the right hand side here, and there are 32 animation frames, and we set each of them. There are 32 of those cards here, so each has the correct animation frame. Animation frame 32 is just blank, so it just shows the blank animation frame when the game starts. So here's the setup. Let me just show you the connection details. The connection details, if you make them visible, are visible here at the top left of the screen. Let me see then. Here are visible here, and they are just shown using this function. Some extra information like the current game, the current instance, the current room. Please review the Construct 3 multiplayer setup documentation if you're not familiar with those terms. And the connect function will just connect to the signaling server. This is a constant. It's just a multiplayer server from 0. So when we connect, this is fired when the connection to the signaling server succeeds. While logging in, we join a room called default and an instance called default, and we just say we were logged in as that alias. And we call the refresh connection details, which I just showed you. For the host, we also append you are the host. When someone joins the room and it is the host, we will something special will happen. The host always has the W1 distribution. This info is actually automatically added the player distribution in the player names dictionary, and therefore he's the first person of the four persons logging into the game. When the peer connects, the connection details are refreshed for that peer. And the host will get some extra information as for the players have connected. So if this player distribution doesn't have the peer ID yet, when the peer connects, the player distribution and the player names dictionary are complete depending on the order the persons connect, and they will get the correct this player distribution. So here we have the calculation to do that, and we add the multiplayer peer alias to the player names. And then we communicate that with the other players. So these kind of functions, send and broadcast, are actually functions that are defined in the outgoing event sheet. They communicate towards other peers. And there's also an incoming event sheet that handle those communications and then do something accordingly. We'll come back to that in a minute. So the player distribution, when there are 4, we will start the game. We will broadcast the fact that we have started the game, and we hide the connection dialog. So when there is a signaling error, we just append an error message for debugging purposes. If the device doesn't support multiplayer, we will say so. And when the peer disconnects, we will broadcast that to the rest that the peer has disconnected, and we show the disconnection dialog. So as for the interaction, that's what happens when the user wants to click. When the cursor is not over a card, we will call reset card hover. Reset card hover is this function. We pick all of the cards and we set the scale back to 1. When the cursor is over cards and the cards are my own cards, so they have my ID and the player is my distribution, and we can make a move, then we'll pick the nearest card to the relative to X and Y of the mouse, and if it is valid, we will set the scale to 1.2, so it becomes a little bit bigger. So once we've done that, on left click, and the move is allowed when the player picks a card, so he's allowed to do that, and the card is valid, the move will be executed. If the player is the host, the move will be executed. However, if the player is not the host, the result should be sent back to the host. That's what I told you here in the communications explanation. The host will then handle the answer and set the feedback to every peer, including the one that just sent the reply. In that logic, the execute move of the peers will happen. So that's what happens here. And in every tick, in essence, on every tick, a player's cards get the contrast effect enabled if the card is not valid. It's not the player's turn or the cards of every other player. The effect is not applied, of course. So that's what happens here. We check is move valid a function if it returns 0, and it's my own cards. Then I just enable the effect. Now let me just show you some more information on the communication between the host and the several peers. So you can see there are two event sheets, incoming and outgoing. In the outgoing event sheet, you can see all of the functions used to communicate outwards. So we can send the player distribution, send the player names, send update of the player info, send the dealer, send the player cards, etc, etc, etc. And they all work in exactly the same way. Either we broadcast, which means that I will send information to every peer, or we send a message to a peer to a specific peer, and in all of the cases that's sending information to the host. So send to peer multiplayer.host ID. For example, send query trump goes from the host to a peer when there needs to be a trump chosen. When the person chooses a trump, he sends that reply back to the host, and then the host does then a broadcast to all of the other peers to say I've chosen, or the person that chooses the trump card has chosen that specific trump card. So they all work in exactly the same way, and you can see that in some cases JSON has been sent along. Player distribution.asJSON is being sent along as a message for the tag player_distribution. And sometimes it's also a concatenations of information, so like the layout, which will be a number of 1 to 8, corresponding to the 8 placeholder layers here, and then a serializing dictionary, also as JSON. There is a serialization dictionary here in the data, and that doesn't really do much except for accepting JSON as an input and serializing it to a dictionary, or vice versa, having a dictionary and serializing it as a JSON information to send over the network. We will see that in a few minutes how that works. So basically they all work in the same way. You can review them, what they exactly send over the network. It's more important to know what they do than exactly how they do it, of course. And then there's the incoming event sheet. So these events handle all of the incoming messages and handle them accordingly. So when the player distribution is received here, the dictionary is cleared and set up using the message content. It uses the serialized dict here to load the JSON, and then for each key in the serialization dictionary, the player distribution is set up. The same thing happens for the peer messages for player names, where the serialized dict is used for player names here. So on update player info, some player information will be updated on the white border at the info on the screen. On peer message dealer means the dealer's changes, so the information of the dealer is shown. Query trump is received when the player has to choose a trump card. So then we will choose the trump dialog. We will show the trump dialog. Trump reply is received by the host when the player has chosen the trump card. And on peer message of trump is received by every peer when the host communicates back which trump card has been chosen. And the same question and answer logic is implemented for the tapping behavior using Tree. So here we will send the distribution of the cards. So when dealing the cards, we deal the 8 cards to every player. This is what happens here. The cards of distribution W1 has been sent to the peer. The info message is concatenated at on the end of the layout, being 8 to 1. And a set of cards is in a JSON format. The information is parsed out, and the dictionary, the serialized dictionary, is again used to loop through the different player cards. So that happens 4 times here. So every time the player changes to indicate that it's his turn, this current player peer message is received. So to indicate that this is the player's turn. Every time a player needs to do a move, the host will send the query move message to the peer that has to make the move. So this message is received by a peer when he or she is expected to make that move, and at that time the move allowed is set to 1. If the player is not the host, in order to make the correct decision And to highlight the correct moves, the turn moves dictionary is used as well as some other variables that make up the logic. These are sent in a message and parsed out automatically. The essence to know here is that the turn moves actually represent all of the cards that have been put on the table up until that point. And the other variables are very inherent to the way the game works, actually the rules of the game. You just have to remember they are used to evaluate if a move is valid or not. So the move reply is then sent back to, is received when a reply has come to the host, and move will be sent to all of the peers, and executing this here, the host will be sent will send a move to all the peers, and the peers will execute that move. The on message consolidation is the process of gathering all of the cards and moving them to the winning player of the turn set. The cards in the turn set are distributed in a message, and they are consolidated using the consolidation move. I will come back to that on that function later. It's just to arrange the cards a bit on the hand of the player. So when the game starts, we hide the connection dialog, and when we show the score, when the peers need to show the score dialog, the correct score is given along a set of two JSON strings separated by an @ sign. These are parsed from the message, and then the points dialog will show the points based on the two dictionaries. Hiding the score has to hide the score, of course, and this is received. The trump chooser, is received when the host sends the trump chooser to the peers, and then shows the information on the screen. On message tab choosers received when the host sends the tab information to the peers, and then shows them on information on the screen. So on peer message rearrange, we will have to rearrange the board, because in order not to leave gaps in the player's hands, we will have to rearrange the cards. We'll come back to that in a minute. When a new round has started, we have to hide the points dialog, of course, and we have to put the cards back to the dealer starting point to make them distributed nicely again. And when we're not the host, we have to clear the turn moves, we have to initialize the trump icons, set some generic titles back to an empty string. On peer message disconnected notify, we will show a disconnection dialog. When the peer sends the last cards over, when the host sends the last cards over, then the peers will have to fill this dictionary and show the last cards on the display. And clear the last cards just means that we pick all the last cards, and we set the animation frame to 32, which is an empty animation frame, so they are actually hidden from the user at that time, and that's usually done when a new round starts. So now we come to the bulk of the logic of the game, and this can be found in the functionality tab, functionality event sheet. So it contains quite a few number of functions, which I'll go over and see what they do actually. The update player info function. This function will update the information on the board. So first we determine the distribution of the player itself. It's just done by checking the peer ID by the value in the player distribution. So remember, the player distribution takes care of the mapping of the W1, W2, Z1, Z2 to a peer. So for each value in that peer, we search for that value of my ID, and my ID in the multiplayer plugin is my own peer ID. And what we do is we set the variable by distribution to the current key. That's very handy, because then later in the logic we don't have to do this for each loop anymore. We can just store my distribution in a variable and take it into account. So next we will pick all of the player names, and depending on the distribution of the player name, the other player names are assigned across the board. So remember that the current player, the player who's sitting in front of his computer and having the application open, will have their own cards at the bottom of the screen, and depending on where this player is and what this player is as the distribution, W1, 2, Z1, 2. It will be, the other players will be on the left side, the right side, or on the opposite side. So that's what we do here. So remember, we have an ID field in the player. For example, this is the player name, and there is an ID field. This is the 0, 1, this is the 1, this is 2, and the other one there is 3. So we pick each of them, and we know that the 0, 1 is the one facing towards us. That's the player, the my ID of the player. So it's the distribution of the player playing the game in front of his computer, W1. So that's what we have here. We set it visible, and we get the player name. Same thing for player name 1, and then we have to do a little calculation, because if my distribution is W1, my distribution is the variable set here above, then the one with player ID 1 is the one sitting in front of me, opposite to me, and that's my teammate. That means that we have to get the W2. But if my distribution is W2, then we get W1. If my distribution is Z1, then we have to get the teammate of Z1, which is Z2, else we get Z1. So that way we can actually determine our teammate, which is in player name 1, opposite to the player playing the game. And the same happens actually for 2 and 3, which is the two opponents sitting right in front of each other, and with the same type of formula, not exactly the same one of course, but the same type of formula, we can determine which player name is which. So next we select all of the placeholders and assign the peer to be able to be select them in the future in other functions. So that's a kind of a setup. We pick all the placeholders and we set the peer to the multiplayer ID. So that's all my placeholders for 0. This is for reference point 1, set the peer. This last cards set distribution of set distribution to my distribution. So these last cards also have an ID. These reference points have an ID. The placeholders have an ID, and they also serve exactly the same purpose as what they did here with the player names. It's just an assignment of either a distribution or a peer or both for the future of the game, when a game is going to be played, to know which name, which placeholder, which reference point, which last card is actually belonging to the player using the ID functionality. And that way we actually circumvent is a bad word, we actually handle the fact, the complexity that everything is relative to the player playing the card on his own computer, and not everyone is in the same position towards the host. So we do the same thing here for ID1, the same for ID2, and the same for ID3. And finally we update the team information. In the top right panel we have to say, okay, our team is that, and their team is that. It's just our team is W1 and W2, them is the other team, Z1 and Z2. It's just a concatenation. So next function we're going to talk about is the start game function. That function is called whenever the game starts. When every player has been loaded, every player has connected, then we will call this function start game. And when the game starts, of course, we also send the update information, and we update the player info here. So update player info, that is this. And then we also have to send out a message. So every function starting with send or broadcast, per definition, is a function you can find here in the outgoing function. And actually what it does, it's very simple. If it says send something, it will send a message to a certain peer. Send to peer, and then the message is send query Trump. It's just a message to a certain peer. But if it says broadcasts, if the function starts with the word broadcast, it will broadcast it to all peers. So that's actually what it does. And right now it's not very important for you to know what exactly it sends over the network. Sometimes it's nothing. some sites it's just a notification, which is start game, for example, and the content of the message is empty. That serves as a notification for the other players, or for the application of the other players, to know, okay, the game has started. I have to do some logic as well. So it doesn't really not so important on what it sends across the network here. Feel free to check it out, because of course it's essential to the game, but in my explanation here, it's not really that essential that you know exactly what and exactly how it's sent over the network and how exactly it is parsed at the other side. So let's get back to functionality. So the send update player info takes care of setting the player info I just explained to the other peers in the network. So the points of the games are cleared. The points are stored in two dictionaries, score W and score Z. So score W is the score of the player, of the host and his teammate. Score Z is the points of the two opponents of the host. You have to see it that way. It is stored in a dictionary because actually to list up all of the points at the end of the game, you have a points dialog, and all the points, the history of the points is below one another. So last round we scored that, last round we scored that, the round before we now scored that, and stuff like that. That's because it's that's why it's in a dictionary. So, and the current dealer is reset. So the first dealer can be determined later on. So the current dealer is set to quote. The first round will determine the next dealer, and then we can take it into account. If it's just being started, the current dealer will be quote. And next, the round is started just by calling next round. And next round, that's this function here. We will add 1 to the current round. It's a variable to know how many rounds there exactly are, and then we can distribute the cards. We will come back to that function, and then we can also broadcast new rounds. So remember, broadcast will send a message to every peer, and it will notify every peer that a new round has started, so the logic can be executed at the other side of the network for new rounds to be started. We have to also initialize the tapped variable, because by default no tapping occurs. It's just up to the players if they want to tap or not. And by default, whenever a tapper taps, it's also broadcasted. The tapper itself is broadcasted. But as there are two players tapping, there's only one time we will tap the broadcaster. Yeah. And that's what the second variable is for. So move allowed defaults to 0, current turn set is 0, the current points of the current round is set to 0, the last cards in the interface are cleared, and the last cards, not in the interface, excuse me, this is the dictionary that will hold the 4 last cards, and we also have to broadcast clear last cards, so the interface actually will disappear, so all the last cards will be set to blank. So distribute cards, that's actually the dealing of the cards. So we start with 32 cards, we shuffle them, and each player gets 8 cards. And that's what happens here. So first we shuffle the permutation table using the advanced random plugin. And now we perform a certain logic 4 times. So W1, W2, Z1, Z2. And each player gets dealt 8 cards. Depending on their loop index, the number is obtained from the advanced random plugin, and the correct card is used using the permutation number instance variable unique card. So what will happen here in the permutation table, it contains a number from 0 to 31, and each card in the deck also has a number from 0 to 31. Once we shuffle the permutation table, each index in this permutation table will hold a different number. So the first index will hold number 27, the second number 13, the third number 1, for example. It will be shuffled together. And now what we do is we cycle from 0 to 7, meaning the 8 first cards in the permutation table. We will pick them using the permutation as the loop index. And then we will add that card to a serialization dictionary. And once that's done, we will send the player cards and we will set up the player cards. What's the difference? The send the player cards is, as you might expect, a function that will send information across the network. It will send that serialization dictionary as a JSON information to the other players. And it will say, okay, these are the cards being dealt to player W1. But for the host, he never receives that because the host itself is sending the message. It's not receiving that message back. So for the host, we also have to do a function called setup player cards, which will set up the player cards on his own board. Actually, in practice, when the message comes in at the other side of the network at peers, and the message comes in, here is the player cards with the JSON information. The JSON information will be deserialized and the setup player cards will be called for their board. So that's in essence, and that's also why this is a function, because the host will be able to execute it and the peers will also be able to execute it when they receive this notification message. Same thing for W2 being cards 8 to 15 and sending player W2 and W2. Z1 16 to 23, same thing, and Z2 24 to 31, same thing. Very simple distribution of the cards. The set of player cards is actually what's being called in distribute cards. And this seems a bit complicated, but bear with me. So there are two things going on. So this function will receive the cards to be set up by reading the serialization dictionary that was just created, or that was just filled, either by the distribute cards function or by receiving it from the network. In order to have the effect that colors are switched at the user hand, meaning that no two black suits can be beside one another and two red suits can be beside one another, these are split into 4 arrays for one suit. So first we pick the peer ID from the player distribution. So this player is the parameter being passed in. We're doing this for player W1, player W2, etc. So we get the peer ID from the player distribution. And there's also a layout being passed along, meaning, okay, we have to use the layout for 8 cards, for 7 cards, for 6 cards, for 4 cards, for 3 cards, and stuff like that. Because the set of player cards will not only be called when starting the game and giving the player each of 8 cards, it will also be called when the first turn set is done, because each player will now lose 1 card, and there are 7 cards left. In order to make them more compact and not leave holes in the card layout, we will call this function again, but with a layout 1 less. For example, after the first set 1, we will call it with layout 7. After turn set 2, we'll call it with layout 6, and stuff like that. That's the idea. So now we create actually 4 MC arrays. C stands for clubs, D for diamonds, H for hearts, and S for spades. And what we do here, we do some checks to determine the order of the suits. So when the order is determined, a loop through the X element of each of the arrays are done, and the cards are picked by suit and value. So the first step is the serialization dict. We loop through the serialization dictionary, for which we know that it contains the cards to be set up. And then we say, okay, the serialization dictionary, if it starts with D, so the mid function 0 to 1 gives you the first letter in the string, so it starts with D, we will push it back on the D array, start with an S on the S array, etc. And once that is done, we first check if we have diamonds, and if we have diamonds, we loop through the hearts, and looping through the hearts, what we do is we pick a card by handling his suit and his value, but in the array here, the values in the player distribution and hence in the arrays, because they were filled using the player distribution, is a concatenation of a suit and a value. Before, for example, H7 is the 7 of hearts, or CQ is the queen of clubs, for example. And then we pick the correct placeholder for the correct layout and the correct counter. And then we set the peer ID. We move it to the placeholder X and Y. We set the counter and we add 1 to the counter. So that's how we do it. So what do we do here? If the d_array.width is bigger than 0, it means there are diamonds. Yeah, there are at least 1 diamond in the player's hand. If there are diamonds, we can show us the hearts, and if there are clubs, we can show the spades. Else means there is no spades. There is no clubs, then we have to show the diamonds. If there is none, then we have to show the hearts. And if the clubs array is not width is different from 0, meaning there are clubs, we have to show the spades. And finally, what we do, is we pick all of the cards for the peer ID. So everything we set up here, we pick it again. We do that in order ascending. We stop the animation, because remember, cards have an animation, one with the front facing and one with the back facing. So we stop that animation. If the player is my distribution, we will set them front facing, otherwise we will set them back facing. So only the player's cards are front facing and all of the other cards are back facing. We set the angle correctly, because otherwise all of the cards will be like a regular card, like it were facing the player playing the card, but that's not correct. It should be rotated according to what according to the place that the peer is sitting relative to the player playing game. And then we move them to the top of the layer, and that's why we also do for each loop ascending by its counter, so they are nicely stacked on top of one another and not somewhere in the Z index, which they're not supposed to be. So that's the setup player cards. Rearranged board is very simple. This function is called whenever a turn set is complete and all of the cards of all of the players need to be rearranged. So they need to be neatly next to one another. To do that, the rearrange cards function is called for every player. So it's very simple. A rearrange board does 4 times rearrange cards, once for every distribution. And the rearrange cards is also pretty simple, because what we're doing here, actually the serialization dictionary is filled again. To let the set of player cards, which is explained above here, can just let the logic flow again and set the new set of cards. That's it. So here we fill the serialization deck and we've set up the player cards. Update detail information. Well, the only thing we do here is display some information. Here we set the dealer on the info on the right hand side of the screen, or we set the trump. So this function is called when the trump suit is chosen. It's given as a parameter, and the icon should represent the trump icon. So these icons are picked and then they represent the trump icon. But if the host is executing this information, it should also broadcast the trump to all of the other peers. And then what we do is, once the trump is chosen, the host needs to ask which player wants to tap. And that's why we do a condition here, if it is the host. And depending on the current dealer, we will ask other players if they want to tap or not. So if it is the W1 or W2, we don't have to send the query tap. We have to, the current dealer is W1 or W2, meaning that it's our, the hosts. The host is W1, remember, so it's the host actually current dealer. So actually there should be a tapping interface for Z1 and Z2. So we will send information over the network telling Z1 and Z2 to be able to tap. It will show the dialog at the other side of the screen. And it will also broadcast the tap chooser. So the tap chooser is the players who are able to choose taps, because then the information on the board will say person X and person Y are deciding on tapping. That's what it says. So when the current dealer is one of the opponents, there should only be one query tap to the teammates of the host, and for the host itself it should show the dialog. It shouldn't send something over the network, it should just show the dialog. So that's what happens here. So the function setDealer is very simple. We call the dealer, we set the current dealer to the dealer, and this current player is also the dealer, and then we update the detail information. And if it's the host, it should also send that information over the network, should tell all of the other peers who is the dealer at this point. Set tap. The host must see using if a tap has been made. So one player has tapped, this information is set to yes. If subsequently the other tapper presses that no, yes is still dominant. So once one player has tapped yes, it's yes. So if there has been tapped and the tapper hasn't been broadcasted yet, it should be broadcasted, and the tapper should always be visible on the host screen. So that's what happens here. And also set the tap variable to take it into account when the points are counted. Update the text, very simple. And if there are two persons have tapped, they must broadcast that information in initialize the turn set and start the logic for the next turn. So that's what we do here. But only if two players have sent back their information. Set current player is very simple. We broadcast that we set the current player to the player passed as a parameter, and we broadcast that information, and we set the text. And next turn will actually determine the next player and the current player, excuse me. And so it will call this function set current player. If best player is empty, the game has just started, so we start with W1. If it's W1, we choose W2. Z1. If the current player is Z1, we will choose W2. If the current player is W2, we choose Z1, and otherwise we choose W1. That's it. So if the current player is my distribution, I'm allowed to do a move, and we set this flag so the user can choose a card. Else, the query to move has to be set to the player that needs to make the move. So we send the query move to the peer being able to move, and at that time his move allowed will be set to 1. So execute move is one of the essences rather of this game. This function will effectively make the move, but some extra logics need to happen here. First of all, the cards have to be moved, are picked, and the placeholder with an index 99, which is one in the middle of the board, being selected. The card is moved here front facing. So that's what we have to do. We pick the cards with the correct card with the move, and the move is just the move parameter is a concatenation of the suit and the value for it. For example, the move that has been made is H7, the 7 of hearts. So we pick the 7 of hearts and we pick the 99 placeholder, which is the placeholder in the middle here. It's right now, it's hidden. One of these ones are the 99s. So that's what's been done here. We use the last card dictionary to show when the turn set is done. The logic below is very specific to this kind of game. It will not move into details on how the rules work here. Instead, you can replace it with your own logic. In essence, the logic below will determine which player is the best player in the turn set, taking into account the value of each card, who has bought the card, using a trump card. This function is executed 4 times by the host, each time for a move that has been communicated to him by its peers. It keeps track of the best card, best non-trump card, best player, and ends the move when everything has been made. All of this information has to be sent to the peers for them to highlight the cards that are allowed in the context of the current turn set being played. So the host will broadcast that move and move the turn set into move it to the turn moves to take it into the count further on. Then there's a helper variable to if the current trump is clubs, we will set it to C. If the current trump is diamonds, we will set it to D, etc. It's just to help us further on in the logic. And then there's no card on the table yet. The best card is empty, so the first card can be played. And then everything else is just depending on how the rules are filled in. I am letting you depend the rules in your game. Once turn moves.key count is 4, meaning there are 4 entries in turn moves, so 4 players have made their move. And the 4th turn has done, the next player becomes the best player. The cards stay on the table for 1 second for everyone to see. And next, the consolidate move is called to make the cards, to move the cards to the correct side, being the side of the best player. And that's what consolidate move does. And then that information is also broadcasted to all of the other peers for them to do a consolidate. We call the count points move to add to the count dictionary, to the counters dictionary, and we clear the turn moves. Reset some variables again, add 1 to the turn set, and we arrange the board. That's what we already saw. So the layout is there 8 minus the turn set. And then we also broadcast the rearranged board for layout 8 minus turn set. We show the last cards, we broadcast the last cards, and if it's all been done, if the current set is 8, meaning all of the 8 cards of all of the players have been played, we show the points dialog. If that's not the case, we will have to call the next turn, and if it's not turn moves is not 4, we also have to call the next turn. So that's the essence of the game here, checking if that's correct or not. If checking if not checking if it's correct, excuse me, is just checking which player is the best player. So the consolidate move takes the best player as a parameter and will move all of the cards to the right direction, the direction of the best player. In order to do that, we pick all of the cards in the turn moves dictionary by selecting it, using its suit and its value, and moving it to the reference point. That's actually it. Is move valid? This is the most important function of the game, no doubt about it, next to execute move, as I just explained to you a few minutes ago. It determines all of the rules within the game. The function returns a 1 if the certain move passed as a parameter is valid or not. You should implement it using your own logic. The function starts with the assumption that a move is invalid, but whenever the logic determines that it is, the value is set to 1. I'm not going to go in detail on the specific rules of this game, feel free to check it out, but most importantly, apply it to your own logic. And bear in mind that when you return a 1, the card will be available for clicking by the user. To help debugging, all situations where a move seems valid are divided into scenarios. That scenarios can be displayed on the screen for debug reasons, actually. So, nothing on the table, if nothing on the table, result is set to 1 and the scenario is 1. And then all of the other logic happens. Feel free to check it out. The next few functions are some helper functions for the isMoveValid to be able to allow making the correct decision. Player has suit will just determine if a player still has a certain suit on his hand. The guy get the highest of suit will just determine the highest value of a suit on the player's hand. Has only trump will determine if the player only has trump cards on his hand. And then there is the count point function, which is also a function that you should implement for the logic in your game. But here the logic just says if the move's third character is an M, then it counts for 5 points. If it's an A, it counts for 4 points, etc. And those points are added to the points W and points Z variables to count the points of the current turn set. That's what count points does, also something you should implement. Get value from move is also something you should implement. A certain move has a certain value, and for that I don't actually mean the number of points. It's actually a value telling it if it's worth more than a certain other card, yes or no. So given a certain move, we get a value. For example, if it starts with if it ends with an M, the value is 14, so that's better than an A, which is only 13, which is better than a K, which is only 12, etc. So you should return an index here for the actual game value of the card, not the actual point value, which is something else. And then some extra show functions to show the trump information on the right hand side on the white area, showing the info tappers on the white area. So with the white area I mean actually this area here on the right hand side. Show tappers shows the tappers on the white area, and show the last cards shows the last cards on the area. The function will pick the cards that have been stored in the last cards dictionary and set the animation frame to the correct card. We first get the card that was played by the value and the suit, and use the permutation number instead as an instance variable of that card to select the correct animation frame. So we reuse that permutation number here actually. Alright, that was a very lengthy tutorial for a game that was pretty complex. I hope you learned a lot. Feel free to get the game at the Sierra store if you want to study it in detail for all of the techniques being used, or if you want to create your own custom card game where you will have to implement your own rules, implement your own is valid move, implement your own get valid move, etc. As always, please like and subscribe. I will leave the link to the Sierra store in the description of the video. Thank you for watching.